Hi everyone, here's a quick example of how we make use of the cosine rule in problem solving, and the problem we're presented with here is we have a triangle with an angle of 50 degrees here at vertex x. We do not know the length of side small x. We have the length 2.1 for side y and 3.9 for side z. So I'm going to choose the cosine rule for this one, because the angle that we're dealing with, the angle we know, is the included angle between the two sides that we know. So the cosine rule then, I'm going to have to remember that if I want the angle to be the cosine of x, then it's got to be x squared, little x squared at the start. So x squared, now the other two are y squared plus z squared minus 2 times these ones, y times z times the cosine of x. So the side x at the front corresponds with the same name, the angle x, and in the cosine function. And that's fine because we know everything here on the right hand side of this equation. The cosine rule is the perfect one to choose when the angle, sorry that was not intended, when the angle that we have been given, the 50-degree angle, is the included angle between the two sides, then the cosine rule is the one to go with. So let's substitute here and see what happens. Y equals 2.1, z was 3.9, minus 2 times 2.1 times 3.9 by the cosine of 50 degrees. I should have still had squared on that, shouldn't I? So let's get the calculator going and we'll see what that comes to. Just make that go a little bit further. 2.1 squared plus 3.9 squared minus 2 times 2.1 times 3.9 times the cosine of 50 degrees. Just double check your calculator is on degrees, not radians. And I have 9.09. That's 9.09, but of course that's x squared, so I'll need to take the square root of that answer. Common mistake is to stop there. So I need the square root of the previous answer, 3.02 if I round off. 3.02. And our unit was centimetres. Now I haven't solved the triangle by any means. I've found the unknown edge, x. To solve the triangle completely, I need to know both of these angles. So that's a job for the sine rule. Let's continue then. So the sine of x over x, let's go with sine of y over y. Now I must of course start with one of the angles that I do know, so I'm searching for this unknown angle down here now, aren't I? So let's see what we get. I would have y over x by the sine of angle x equals sine y. Now y equaled 2.1, x was our previous answer, 3.02. The angle at vertex x was 50 degrees, so that's the sine of 50 degrees equals the sine of y. Time for the calculator again, of course. So we'll have 2.1 divided by the previous answer multiplied by the sine of 50 degrees. 0.53, that's reassuring that it's between 0 and 1. Of course, sine has to be between 0 and positive 1 and negative 1, so that's good. What do we have there? 0.53, if I just write down 2 decimals. So the sine of y equals 0.53. That was the sine of y. y therefore will be the inverse sine of 0.53. Sorry, I hit the wrong button then, didn't I? Get all the way back to where I was. I want the inverse sine. Now I hope I haven't upset my calculator by doing that. That seems about right because the sine of 30 is 0.5, so that's just a bit more. That's 32. I might just go to the nearest whole degree this time, 32 degrees for angle Y. Now don't forget the CAST, the old cast rule. If I have an angle here of 32 degrees, then inverse sine in the second quadrant would be 180 minus 32 degrees. So I could have 148 degrees. I could have an obtuse angle. Well, let's just double check that. Maybe we could. The existing angle in the triangle is 50 degrees. Now we all know that the sum of the three angles must be 180. So a 50 and a 32 is fine, that's less than 180, but a 50 plus 148, that's already exceeding 180, that could not exist. There's only one answer for this one. This is a sine rule where there wasn't an ambiguous case, but we should always consider the possibility. Now if I have angle Y of 32 degrees, then really it's child's play to find angle Z. That's just the angle sum. So angle Z then is 180 minus angle X minus angle Y. Angle X was 50, wasn't it? Yes. Angle X was 50. Angle Y is 32. So by the time we do that, we're subtracting 82, we have 98 degrees for angle Z. Now we've solved our triangle. We know all three angles. We know there wasn't an ambiguous case, so we didn't have to worry about that, but we did check it to be sure, and we know all three edges. That's how you solve a triangle. Remember the key point to this one? The given angle, 50, was the included angle between the two given sides. That's what tipped me off to using the cosine rule straight away. All right, have fun solving triangles.